Good day to all the students. In this class, we see the IUPAC nomenclature of coordination compounds. 5.4. This is a simple way to write the nomenclature. Then using the nomenclature, we solve the book back two questions, question number 5 and 6. In this IUPAC naming, this is a IUPAC name writing procedure. In exam, don't ask IUPAC naming method. Only asking question is they give the structure of the compound, like this. They give the structure of the compound. You write down the name. Otherwise, reverse, name is given. You write the structure of the compound. This is the questions based on IUPAC name. Using these points, that simple points, we write the IUPAC name. Initially, the name is based on a discoverer name. That is, initially, this complex is called Cisse salt. Second, this complex is called Magnus green salt. That is, name is given based on the discoverer name. And then IUPAC naming method comes based on these points. First point number 1. First name given to the, that is, first name given to the cation, that is positive ion. This positive ion may be like that of potassium, simple ion. This positive ion may be simple ion or like this complex ion. If it is a simple ion, positive ion, usual name, that is cations, positive ions, usual name, likely cation also usual name, that is a common name, that is a inorganic names. Example, the tabular column is given. Simple ions, simple cation. The simple cation means the simple anion. How can you identify? The square bracket outside ions are called simple ions. It may be cation or anion. Cation means positive charge, anion means negative charge. Usual name, common name, that is inorganic compounds. Na plus sodium, K plus potassium, Cu2 plus copper. Likely anions, Cl minus chloride, NO3 minus nitrate, sulfate, SO3 minus. First point, first name given to the cation, that is a positive ion. If it is a simple ion, usual name. Suppose this cation, complex ion, if it is a complex ion, naming method of complex ion. Naming method of complex ion. In complex ion, naming the ligand is a first name given to the ligands. If more than one kind of ligand, use alphabetical order. For example, in example 2, in this complex ion, 2 ligands, ammonia, second chloride. Ammonia, alphabetical order, ammonia, first letter A. In chloride, first letter C. In ammonia, first letter A. In alphabetical, A is a first, C is a second. Therefore, ammonia name is given in first. Secondly, chloride ion is named. In this case, amine and chlorido. This is a ligand naming method. Laterally, we see. In complex ion, ligand is named first. If more than one kind of ligand, alphabetical order is using. Second, anionic ligand, that is negative ligands end with O. Cationic ligands, that is a positive ligands end with IUM. Neutral ligands, usual name. In this case, in your book, no neutral ligand is given, but in 1 mark question, NO plus, that is a nitrolium, nitrosilium ion is asked in a book back 1 mark question. And exception case, H2O is named as aqua, CO is named as carbonyl, ammonia named as amine, AMMINE, NO is nitrosyl. These ligands are neutral ligands, therefore usual name. Neutral ligand means usual name, but in case of H2O, CO, NH3, NO, all are neutral ligand. Exception case, special names are given. Now, for a negative ligand end with O, that for this case one tabular column is given. Using the tabular column, we can name it. In this tabular column, common name and formula, IUPAC ligand name. In bromide is simple ion, common name simply bromide. If it is bromide in complex bromido, in this case notable point is in bromide the last E is changed into E is eliminated, add O. Therefore, bromide is converted into bromido, chloride is converted into chlorido, fluoride is converted into fluorido, and so on. In this case, three notable points. This tabular column used to calculate the oxidation state of the central metal ion. In this tabular column, ethane 1,2 diamine, triphenyl phosphine, and pyridine. These three ligands are neutral ligands, that is no net charge on the ligands. In this case, no net charge. Therefore, these three ligands are neutral ligands. Ethane 1,2 diamine, triphenyl phosphine, and pyridine. These are ligand symbols. This is a common names. In this neutral ligand, no change in the name of the ligands, no net charge on the ligand. These points are used to find out the oxidation number of the central metal ions. Next, anionic ligands, that is bromido, chlorido, fluorido, cyanido, hydroxido, nitrido, nitrato, nitrido. These ligands have a net charge of -1. Likely, the carbonato, sulfato, sulfido, oxalato. These ligands has 2 negative charge. Likely, EDTA has a 4- charge. These points are very important to find out the oxidation state of the central metal ion. Therefore, be careful on the charges on the ligands. Next point, ambidentate ligands are ambidentate ligand points. Ambidentate ligand means the one ligand, for example, thiocyanate, formula is Cn-. This one ligand may be bond with the central metal ion either by sulfur or nitrogen. Suppose sulfur bond with the central metal ion, that denoted by kappa S. If that thiocyanate bond with nitrogen, that is central metal ion and ligand, in ligand nitrogen, that is metal to nitrogen bond denoted by kappa N. Likely thiocyanate, metal thiocyanate linkage is denoted by the kappa N. The ambidentate ligand means one ligand has more than one donor atom, that is lone pair donor atom. Therefore, it may be possible metal to ligand more than one way. that ligands are called ambidentate ligands. More than one ligand of particular type denoted by di, tri, tetra, penta, hexa. For example, in this coordination compound CN, cyanide, in six cyanides are denoted by hexacyanido. Hexa, 6 indicated by the hexa. Suppose ligand name itself has di, tri, tetra. In this case, we use the bis, tris, tetrakis. For example, ethane 1,2 diamine. Name itself has the di. In this case, use the bis, tris, and so on. For example, in this complex ion, En is ethene 1,2 diamine. We put the name tris, that is the tris indicates this En is 3 times. In this, why we use this tris means name itself it has a di, therefore use the tris. And then naming of central metal ion. If it is a cationic, suppose if a complex is cationic or neutral, usual name is given. Suppose a complex is anionic, suffix end with ate. For example, in this case, simple ion is positive, complex ion is negative. Put the name for the Fe, central metal ion, end with Ate, that is a Fe anionic complex, therefore ferrate. For this, in a book, one tabular column is given, that is a central metal ion in cationic complex, usual name chromium, zinc, aluminium, iron, copper, cobalt, lead, silver, tin, gold, platinum. Suppose this chromium in anionic complex end with Ate, that is a chromate. Zinc is zincate, aluminate, ferrate, cuprate, cobaltate, fulminate, argentate, and so on. In this case, the important points are summarized. Do not memorize, simply you just one time read. Using that points we can give the name. Now see the 3 examples. given in a book. In this case, one important point, this is a complex. These all are explanation purpose. For exam point of view, complex, directly you write down the name itself enough. Complex and its IUPAC name. These remaining parts, these are these tabular columns are for understanding purpose. Don't need to memorize, just for understanding purpose. In an exam point of view, complex and directly name, these all are given for only understanding purpose. After the understanding, you write down directly IUPAC name is enough. First, simple ion potassium, therefore given the name potassium. In complex ion is anion. In complex ion, first name is ligand CN. In this case, totally 6 ligands, therefore hexa is used. Anionic ligands, this cyanide is end with O, because it is a negative ion. Therefore, hexacyanido, kappa C means the metal ion, metal and CN link via carbon atom. Therefore, kappa C is given. And then central metal ion, Fe is anionic nature, therefore ferrate. The oxidation state of the central metal ion, oxidation state is Ex. One CN has 1 minus, totally 6, therefore 6 into minus 1. This net charge on the complex ion is determined by one potassium has a 1 plus, totally 4 potassium, therefore 4 plus. For a balancing, 4 minus comes, that is the net charge on the complex ion. For find out X, this minus comes opposite side, plus 6 minus 4 equal to plus 2, that is oxidation number of the central metal ion, therefore in the form of Roman letter 2. Therefore the complex ion name potassium. Important point, the space is given through the simple ion and complex. After the complex, no space is given, that is a very important point. Therefore hexacyanido, that is 6 cyanide ion, kappa C ferrate 2. Example 2, cationic complex. In complex, first name is ligand. In this case, 2 ligands, NH3 and Cl. If more than one kind of ligand means, use the alphabetical order, that is alphabetically amine comes before the chloride. Therefore tetraamine dichlorido, tetra means 4, di means 2, that is 4 ammonia 2 chloride. This O come for the chloride negative ion. In complex, within the complex ion, chloride is converted into chlorido. Chlorido means a negative ligand. Amine is a special name for ammonia. Central metal ion is cationic complex, therefore direct name cobalt. Oxidation state of the central metal ion, in this case X. Ammonia has a neutral ligand, therefore 0 into 4. 2 chloride ion, therefore 2 minus 1 chloride ion charge is minus 1. Net charge on the complex ion is plus 1. That is given directly in the complex ion superscript. Therefore, the simple ion chloride within the complex ion chloride, this is outside of the complex ion, therefore chloride. In this case, net charge Cl has a 1 minus. For our balancing, plus 1 comes. Therefore, this plus 1 is put on the complex ion. Therefore, tetraamine dichlorido cobalt 3 chloride. In this case, space only given to the simple ion between the 3 and chloride. Third example, cationic complex. This plus 3 net charge on the complex ion based on the charge of the ligands. En is a neutral ligand. F has a minus 1. Therefore, total is 6 minus. In this case, 2 ligands. Therefore, divide by 2, we get the minus 3 for this complex, cationic complex. For balancing, that is minus 3 on the anionic complex. For balancing this is come as plus 3 complex ion, that is, therefore this is the cationic complex plus 3. First name given to the ligands, therefore ethylene diamine 3. In this case, di is already in the name, therefore this 3 En is denoted by tris ethane 1,2 diamine. Oxidation state of the central metal ion X. En is a neutral ligand, therefore put the 0, 3 En, therefore equal to net charge on the complex ion is a plus 3, therefore oxidation state is a plus 3. Second name given to the anionic complex, that is totally 6 ligands, therefore hexafluorido. Oxidation state of the central metal ion X, totally 6 ligands, 1 fluoride, it has a minus 1. Net charge on the anionic complex is minus 3. Therefore, now find, using that we can find out the oxidation state is a plus 3. Now write the full name, tris ethane 1,2 diamine chromium 3 hexafluorido chromate. The chromate, because of these ligands has a, this complex has a net charge is minus, that is central metal ion on the anionic complex end with the AT, therefore AT is given and the oxidation state of the central metal ion is 3. Now solve the book back question. As per IUPAC guidelines, the name of the complex ion is, first point, complex ion is a 1 chloride as a simple ion, 1 minus for balancing plus 1. Therefore, this complex ion is a positive ion, that is a cationic complex. Cationic complex means not end with ATE. Therefore, B option is incorrect. Remaining options, in this case, ethylene diamine 2. Therefore, bis comes. All this complex bis. In the case of first option, ethylene diamine is given directly, that is not a IUPAC name. Therefore, bis after that ethylene diamine in the square, this format. Therefore, option A is incorrect. Remaining of C and D, only change is oxidation state of the central metal ion. For oxidation state, we can find out central metal ion complex, put X. En is a neutral ligand. Therefore, this term will be cancelled. Remaining NO2, that is nitride, that is nitrido, has a 1 minus charge. Therefore, only 1 NO 1 minus equal to net charge on the complex is plus 1. Likely 1 chloride ion has a 1 minus. Put this side. First, X. En is a neutral ligand, therefore cancel out 1 nitride, X, 1 NO, it has a 1 minus, likely 1 chloride has a 1 minus equal to plus 1. These two's plus minus 1, this is a minus 1. Come in opposite side, plus 2 plus 1. Therefore, answer is plus 3. Therefore, correct option is D, that is chlorido. Why chlorido is first come means in alphabetical order. Chlorido Cl, nitrido N, ethylene diamine E. In alphabetical order, first ligand is come in C. Second alphabetical order, first chlorido, second ethane 1,2 diamine, third N, that is a nitrido. Therefore, the first name is chlorido bis ethene 1,2 diamine nitrido kappa O. That is kappa O is central metal ion. This nitrido N bond via, that is nitrido oxygen metal ligands. oxygen metal linked via MO bond, that is kappa O, cobalt 3 chloride. Now first option is incorrect. Oxidation state is correct, but this ethylene diamine is in common name, that is therefore A option is incorrect. In case of B option, cobaltate is wrong. In C option, oxidation state is wrong. Only remaining D option is correct option. UPSC name of the complex. In this case, first simple ion potassium, and then complex ion naming 3. In this case, trioxalato. All the 4 options oxalato is correct, and then remaining is aluminium, aluminate. For a positive complex ion aluminium, in this case simple ion is a plus. That complex is a negative charge, that is anionic complex. Aluminium does not come, therefore A option is incorrect. Remaining B, C, D, oxidation in this case. Another notable point, in a C option tris is given, therefore C option also incorrect. Remaining 2 option B and D. In first case aluminium wrong. In a C option tris is come. Suppose if ligand has a ditri, therefore B option is incorrect. Remaining B and D, only change is oxidation state of the central metal ion. Now find out the oxidation state of the central metal ion. 1 potassium has a 1 plus, totally 3 potassium, therefore 3 plus. For the balancing, complex ion is a -3, therefore it is a anionic complex. 3 minus. Central metal ion oxidation state X, plus 3 oxalates, put 3. 1 oxalate has a oxalate formula one X plus 3. 1 oxalate has a -2 charge. Net charge on the complex is -3. This multiplication -6 comes opposite side, +6. Therefore oxidation state of the central metal ion is +3. One important point, oxalate formula -2, therefore we put the 2-. Therefore correct option is D option. Once again we repeat. In this case, A option aluminium wrong. In a B option, oxidation state is the 2 is incorrect. Third case, tris. Therefore, C option is incorrect. Remaining one is a potassium trioxalato aluminate 3. Now once again, IUPAC naming method, simple points. Using that points, we write down the IUPAC name of the complex. Thank you very much.